Every month, the average American over 55 writes checks they didn't plan for. Gas, insurance, the repair bill that showed up the Tuesday after the warranty expired. You've been told electric vehicles are the future. You've also been told they're expensive, complicated, and built for someone younger. This video exists to give you a straight answer. In the next hour, we're going to cover 3 things in this exact order, because that's the order that makes the math clear. First, the 7 changes Tesla actually made to build a $12,749 car, and why those changes protect your money, not just their margin. Second, what's inside the factory and inside the metal that makes this car cheaper to own year after year, not just cheaper to buy. Third, the 7 engineering decisions that were made specifically for people who've been driving for 4 or 5 decades, decisions that affect your back, your wallet, and how long you stay independent. No hype, no affiliate deals, no pressure to reserve anything today. Before we start, Tesla has not officially announced the Model 2. Everything in this video comes from leaked engineering sources, supply chain reports, and documented patent filings. When something is confirmed, I'll say so. When it's reported, I'll say that too. That line matters on this channel. Let's get into it. Change number 1. Design shifts to compact crossover. Tesla isn't following the cheap hatchback playbook that everyone expected. Instead, leaked supply chain documents and Fremont factory activity suggest they're pivoting toward a compact crossover format. Here's what that factually means in practical terms. The rumored dimensions put this vehicle at approximately 4.2 to 4.4 meters in length, roughly 15 to 20 centimeters shorter than a Model 3, but with noticeably higher ground clearance. The silhouette appears to lean toward a coupe fastback profile rather than a traditional boxy SUV shape. Design elements reportedly include a continuous LED light bar across the front and an extremely minimalist body structure enabled by next-generation giga-casting technology that reduces panel gaps and eliminates unnecessary joints. Now, here's the part that matters for older drivers. A crossover design isn't just about looks. The higher seating position makes entry and exit significantly easier, especially for people dealing with knee problems, hip replacements, or general mobility limitations. You're not dropping down into a low sedan or climbing up into a tall SUV. You're stepping naturally into a vehicle that meets you at a comfortable height. That elevated driving position also improves sight lines dramatically. When you're sitting higher, you can see over traffic better, judge distances more accurately, and feel more in control, especially in parking situations or heavy traffic where spatial awareness becomes critical. For someone who's been driving for 40 or 50 years, that sense of control matters more than any spec sheet number. The fastback roofline might sound like a styling compromise, but it actually serves a functional purpose. By tapering the rear, Tesla reduces aerodynamic drag without sacrificing meaningful headroom in the front seats, where you spend 95% of your time. The real engineering win here is weight distribution and structural rigidity. A smaller, taller vehicle built around large single-piece castings creates a stiffer chassis with fewer failure points over time. So when Tesla says this is a compact crossover, they're not just chasing a trend. They're building a vehicle format that balances cost efficiency with real-world usability for people who need simplicity, visibility, and ease of access. Bottom line, cheap price, but not cheap execution. This design serves actual daily use. Change number 2. Small LFP battery pack. Tesla is betting on a 53 to 55 kilowatt-hour LFP battery pack. Not because they can't build bigger, because bigger doesn't make financial sense for this vehicle's mission. The target range sits around 250 to 310 miles per charge, depending on drive configuration and conditions. That's not class-leading. It's not meant to be. It's optimized for daily driving, not cross-country road trips. Let me put this in perspective. According to U.S. Department of Transportation data, the average American driver covers about 37 miles per day, roughly 13,500 miles per year. Even if you're above average and drive 50 miles daily, a 250-mile range gives you 5 full days between charges under normal conditions. Here's what most marketing materials won't tell you. Range performance scales exponentially with battery size. Pushing from 250 miles to 350 miles often requires 40 to 60% more battery capacity and cost. For a vehicle targeting affordability, that's expensive performance you statistically won't use most of the time. Tesla chose LFP chemistry specifically because it brings 3 critical advantages for long-term ownership. First, LFP batteries are significantly safer than higher-energy nickel-based chemistries. They're far less prone to thermal runaway, which is the technical term for battery fires. For someone on a fixed retirement income who can't afford unexpected repair bills or insurance complications, that safety margin matters. Second, LFP batteries last longer. Industry testing shows LFP cells can handle more charge cycles before capacity degradation becomes noticeable. In practical terms, that means the battery should retain usable range for more years before replacement becomes necessary. Third, and this is huge, LFP batteries cost less to replace if something does go wrong. A 55 kilowatt-hour LFP pack costs roughly $7,000 to $7,500 in raw materials at 2025 pricing, compared to $12,000 to $14,500 for a 60 kilowatt-hour nickel-based pack in current Model 3 variants. That's not just savings on paper, that's real financial risk reduction. Tesla isn't chasing the longest range or the most impressive energy density numbers. They're optimizing for total cost of ownership over a realistic 10 to 15-year lifespan, which is exactly how long most retirees plan to keep a vehicle. You're not buying headline specs, you're buying predictable, manageable costs. And that's a smarter way to engineer an affordable EV. Change number 3. Solid-state donut battery technology. At CES 2026, a company called Donut Lab unveiled something that could fundamentally change the battery conversation: a solid-state battery shaped like a donut. Before you roll your eyes, let me explain why this matters and why I'm covering it despite Tesla not officially confirming anything. Donut Lab's announcement included verified technical specifications. Their solid-state donut battery achieves approximately 400 watt-hours per kilogram energy density.
With donut battery, we set a new baseline, 400 watt-hours per kilogram.
Significantly higher than current LFP or nickel-based batteries. The donut shape creates a natural pathway for heat dissipation that spreads thermal energy more evenly across the cell structure. According to their published data, these batteries charge faster, last significantly longer, and operate reliably from -30 degrees Celsius to 100 degrees Celsius. Now, here's where engineering reality meets marketing hype. Solid-state batteries have been just around the corner for over a decade. Major automakers have announced partnerships, startups have burned through billions, and production timelines keep slipping. Healthy skepticism is absolutely warranted. But Donut Lab's approach is different. They're proposing a hybrid architecture where solid-state cells handle high power demands like acceleration and fast charging, while conventional cells provide bulk energy storage. If Tesla were to adopt a similar principle, even partially, here's what could change under optimal conditions. A 55 kilowatt-hour pack with even 20% solid-state cells could potentially deliver 300-plus miles of range instead of 250 without increasing pack size or weight. Higher energy density means more range from the same physical volume.
Faster charging becomes more practical because solid-state cells eliminate the liquid electrolyte that causes heat management limitations in current LFP batteries. And for older drivers, extreme temperature performance matters. If you live in Florida, where summer temperatures regularly hit 95 to 100 degrees Fahrenheit, or in parts of Texas or the UK, where winter cold affects battery performance, a battery that works consistently across those extremes removes a major source of anxiety. Tesla hasn't confirmed they're using this technology, but credible companies are now demonstrating working prototypes at major industry events, which means this is no longer science fiction. It's engineering that exists today, even if mass production remains a challenge. That's not hype. That's documented progress you should factor into your decision.
Change number 4. Physical buttons return to interior. Tesla is stripping the interior down to essentials, but not in the way you might think. The rumored 10.5 to 11-inch touchscreen is smaller than the current 15-inch displays in Model 3 and Model Y. Seats will likely use fabric instead of vegan leather. Heated seats may disappear entirely. The panoramic glass roof is probably gone, replaced with a conventional metal roof to cut costs. But here's the critical change most coverage is missing. Tesla appears to be bringing back physical buttons for essential functions. After years of pushing everything onto touchscreens, forcing drivers to navigate menus for basic controls, early prototypes suggest Model 2 will have dedicated physical buttons for climate control, hazard lights, and other frequently used features. Why does this matter so much for older drivers? Touchscreens require you to look away from the road, find the right menu, and tap precisely on a moving screen while driving. That's genuinely difficult if you have arthritis, reduced fine motor control, or just want to adjust the temperature without taking your eyes off traffic. Physical buttons provide tactile feedback. You can find them by feel, operate them without looking, and know immediately when you've activated the right function. Voice control remains fully integrated. Tesla's voice command system has improved dramatically and now handles most common requests reliably. You can adjust temperature, change navigation destinations, or control media playback without touching anything. The Tesla mobile app also stays fully functional, letting you precondition the cabin, check charge status, or locate your vehicle from your phone. And perhaps most importantly, the FSD platform remains available. Tesla isn't removing the hardware capability for advanced driver assistance features. The sensors, cameras, and processing power stay in place, which means features like automatic parking, lane keeping assistance, and adaptive cruise control should still function. What you lose are premium touches. Ambient lighting gets simplified to a single color instead of customizable options. The speaker system will have fewer drivers, affecting sound quality. Storage compartments might be less refined. But the core functionality that actually helps you drive safely and comfortably every day stays intact. This is a crucial distinction. Simplification doesn't mean removing useful features. It means removing complexity that doesn't serve the primary mission, getting you from point A to point B safely, comfortably, and affordably. For someone who's been driving for decades and just wants a vehicle that works reliably without requiring a technology degree to operate, this is actually a significant improvement over Tesla's recent direction. Simple isn't outdated. Simple is smart design for real people.
Change number 5. Manufacturing innovation drives pricing. Let's be very clear about what $12,749 actually means. That's the target price point Tesla is fighting to reach, not through gimmicks or corner cutting, but through fundamental changes in how electric vehicles are designed and manufactured. Getting to that number requires solving problems traditional automakers have struggled with for decades. So how does Tesla get there when traditional automakers can't? Giga-press technology is the foundation. By casting large sections of the vehicle structure as single pieces instead of assembling hundreds of stamped and welded parts, Tesla eliminates entire layers of labor, tooling costs, and quality control checkpoints. Industry analysts estimate large-scale casting can reduce structural assembly labor by 20 to 30% in affected sections. That doesn't make the whole car 30% cheaper, but it fundamentally reshapes the cost structure in ways traditional assembly lines can't match. Unboxed assembly takes this further. Instead of building the entire vehicle on a single moving line, different modules get assembled in parallel by specialized teams, then combined near the end of the process. This dramatically increases factory efficiency and reduces the physical footprint required. Here's where the savings add up. The small battery pack saves approximately $6,000 to $8,000 compared to larger EV packs. Simplified interior and reduced features save thousands more across materials and labor. Then add available incentives. The federal EV tax credit provides up to $7,500 where still applicable. Some states offer additional rebates ranging from $1,000 to $5,000. Certain utilities provide further incentives for EV adoption. Combine aggressive engineering cost reduction with every available incentive program, and $12,749 becomes mathematically possible for qualified buyers. It's not magic, it's not accounting tricks, it's extreme optimization across every dimension of vehicle design and manufacturing. Tesla isn't selling cheap, Tesla is engineering differently. And that difference shows up in the final price.
Change number 6. Driver assistance remains standard. One of the biggest misconceptions about a low-cost Tesla is that it won't include advanced driver assistance features. That's wrong. The hardware foundation costs relatively little to include during manufacturing. The cameras, radar, and processing chips are already integrated into Tesla's production process at scale. So even at this price point, Model 2 should include core safety features that actively help older drivers every day. Automatic emergency braking detects potential collisions and applies brakes if you don't react in time. For drivers whose reaction times have naturally slowed with age, this is a genuine safety net. Lane keeping assistance gently steers the vehicle to stay centered if you start drifting. On long highway drives where fatigue becomes a factor, this reduces mental strain significantly. Blind spot monitoring and rear cross traffic alert provide warnings about vehicles you might not see. These features compensate for reduced neck mobility or limited peripheral vision. Adaptive cruise control automatically adjusts your speed to maintain safe following distance. In stop-and-go traffic, this eliminates the constant acceleration and braking that causes leg fatigue. Smart parking assistance can automatically steer the vehicle into tight spots, removing stress about parallel parking or scraping curbs. Advanced full self-driving features requiring a subscription will likely remain optional, but foundational driver assistance features that improve safety and reduce fatigue should come standard. Here's why this matters. These systems reduce the cognitive load of driving. They handle routine tasks in the background, letting you focus on the road ahead. For drivers concerned about maintaining independence but realistic about their changing abilities, these technologies extend safe driving years. The car quietly helps you stay safe without making you feel like you need help. That's dignity-preserving technology design. And it's available at every price point Tesla offers.
Change number 7. Total ownership cost prioritized. Let's talk about what really matters when you're living on a fixed income. Total cost of ownership over time, not the purchase price. Electric vehicles eliminate most routine maintenance that gas cars require. No oil changes every 5,000 miles at $50 to $80 each. no transmission fluid services, no timing belt replacements, no exhaust system repairs, no spark plug changes. According to multiple ownership cost studies, EV owners spend 40 to 60% less on maintenance and repairs over the first 5 years compared to equivalent gasoline vehicles. Brake pads last dramatically longer because regenerative braking handles most deceleration, capturing energy back into the battery instead of converting it to heat through friction brakes. Many Tesla owners report original brake pads still have 70 to 80% life remaining after 100,000 miles. Tire wear is comparable to gas vehicles when properly maintained, and because electric motors deliver smooth, predictable power without engine vibrations, the overall driving experience involves less mechanical stress. Insurance costs for EVs have traditionally run higher than gas cars, but smaller, simpler EVs with lower repair complexity should compress that premium over time. Energy costs tell an even more dramatic story. At average U.S. residential electricity rates around 14 cents per kilowatt hour, charging an EV costs roughly equivalent to 40 to 60 cents per gallon of gasoline when converted to miles driven. Even with some public charging at higher rates, most EV owners pay less than the equivalent of $1 per gallon. Compare that to current gasoline prices between $3.50 and $4.20 per gallon in most states, and a typical driver saves $5,000 to $7,000 on fuel alone over 5 years. Battery safety is another factor most coverage ignores. LFP batteries are significantly less prone to thermal runaway than other chemistries. They're more stable, less reactive, and pose lower fire risk. For someone living in a retirement community or parking in a shared garage, that peace of mind matters. Add it all up, and you're looking at a vehicle that costs less to insure, less to maintain, less to fuel, and less to worry about mechanically. That's what a good retirement vehicle should deliver: predictable costs, minimal surprises, maximum independence. Model 2 appears designed specifically for that mission.
So now you know the 7 changes. You know what Tesla decided to build and what they decided to cut. But here's the question most people don't ask next. They stop at the price. They don't ask, how is that price actually possible without cutting the things that matter? That's what the next chapter is about. We're going inside the factory, inside the metal, inside the decisions that most car reviewers never look at because they're not the ones paying the repair bill 5 years after the review goes up. Before we go there, drop a comment right now. Comment "change" if there's one of those 7 decisions that surprised you most. I read every single one, and it shapes what we cover next.
Smaller body, more space you actually use. Let me start with a number that surprised me when I first ran across it. Based on reported design specifications, the Model 2 is roughly 230 millimeters shorter than the Model 3 and about 80 millimeters lower. On paper, that sounds like less space, but Tesla reportedly increased real usable volume by an estimated 20%, with projected cabin and cargo capacity around 2,450 liters. How? Because they did not just shrink the car, they reallocated space. Most sedans waste volume in the roofline and behind the rear seats. A redesigned roofline and steeper hatchback angle pushes usable depth where you actually store things. Smaller outside, bigger where it counts. Seats, legroom, cargo. Now here is the part that matters if you have knee or back issues. According to reported engineering data, the front doors open about 1.15 meters wide at roughly a 37-degree hinge angle. Inside, reduced seat thickness and a trimmed dash reportedly add around 42 millimeters of knee room. That may sound small, but in ergonomic terms, it's the difference between stepping in cleanly and twisting your hip every time. For anyone with a bad back or knee history, that's not comfort, that's injury prevention. The other number worth knowing is the estimated turning radius, about 5.15 meters versus roughly 5.3 meters on a Mazda MX-5. That suggests the Model 2 could be easier to place in tight lots and narrow streets. Combined with an estimated weight under 1,450 kilograms, it should carry less inertia in stop-and-go traffic, which translates to lower energy use. And lower energy use means lower charging cost every single month. The Model 2 is not trying to impress you with size. It's trying to stop you from paying for space you never use while protecting the comfort you actually need. But getting the interior right is just the beginning. The real savings are not in how the car feels, they're in how the car is built.
Where cheap actually lives, inside the factory. Here's a question no car reviewer ever asks. What does it actually cost to build a car? Not the sale price, the build cost. Because the gap between those two numbers is where manufacturers hide their margin, and where you, as the buyer, eventually pay through hidden repair costs, poor materials, and premature wear. Based on reported supply chain information, Tesla is doing something structurally different with the Model 2 at the manufacturing level, and it matters directly to your wallet. Start with the body structure. Tesla is reportedly developing a new alloy that combines steel, aluminum, and manganese, a material mix designed to balance durability, weight, and production cost. This combination is estimated to reduce body weight by approximately 8%, which is around 45 kilograms less than a comparable steel body. And in electric vehicle engineering, weight reduction is the single most efficient lever for range improvement. Industry research from independent automotive engineering studies, not Tesla marketing, consistently shows that reducing vehicle weight by 10% improves energy efficiency by roughly 8 to 6%. That means less battery capacity needed for the same range, which keeps production costs down without shrinking the usable miles per charge. Now here's a number that deserves more attention than it usually gets. The new material reportedly increases body stiffness by approximately 15%. Estimated testing data suggests the frame reduces deformation by about 20 Newton-meters per degree of torsion. A stiffer frame means the suspension does its job more accurately, the steering returns clearer feedback to your hands, and the doors stay aligned for longer. A frame that flexes less rattles less, and that rattling, that creaking, that door that starts sticking after 2 winters, those are the early warnings of a car quietly degrading in structural quality. Here's something the automotive industry does not advertise. Dealership service departments make a significant portion of their revenue from exactly those small recurring failures, rattles, squeaks, seals that let moisture in. The Model 2 is reportedly engineered to suppress that process before it starts. That is engineering against the service bay, not for the showroom. But the most aggressive cost-cutting move Tesla is reportedly making is one most people have never heard of. Traditional automotive paint, the multi-layer process every car you've ever owned went through, can reportedly cost up to $3,000 per vehicle to apply. It requires massive temperature-controlled spray booths, dozens of chemical layers, extended curing time, and enormous energy consumption. Tesla is reported to be developing a technology called dry coat finish, which uses a metallic vapor deposition process. Instead of spraying chemicals onto the surface and baking them in, this process reportedly bonds metallic coating directly to the alloy at a molecular level. The estimated result, approximately 40 kilograms of CO2 eliminated per vehicle during production, significantly shorter finishing time, and a surface that is structurally harder than traditional polymer paint. When color is integrated directly into the material rather than applied on top of it, it is estimated to resist scratches better, hold up against UV exposure longer, and not peel or fade the way standard paint does after years in the sun.
For someone who parks in a driveway in Florida or Arizona, that's the difference between a car that looks 10 years old at year 4 and one that still holds its finish at year 8 without expensive paint correction. And a car that holds its finish holds its resale price. That's money back in your pocket when you decide to sell. Cutting the paint process isn't cutting quality, it's cutting cost at the factory while delivering a surface that performs better over time. Now let's get into the details that most reviewers completely ignore, the small components you touch every single day that when they fail cost you far more than their size suggest.
The small things that drain your wallet quietly. There is an old rule in mechanical engineering. The component that fails most is not the most complex one. It is the one you use the most. Think about your current car. What do you touch more than anything else? The door handle. Every single day, multiple times, in heat, in cold, with wet hands, with gloves on. Most vehicles treat the door handle as an afterthought. Based on reported design direction, Tesla is treating it as a primary reliability target on the Model 2. According to reported specifications, the Model 2 reduces door opening force from approximately 30 newtons down to 18 newtons. That is a 40% reduction in the mechanical stress placed on the handle mechanism with every single use. Less force means less wear on the internal components, less stress on the mounting points, and a longer operational life for the entire assembly. Reported cold weather testing data shows the Model 2 door handle maintains stable operation in an estimated 980 out of 1,000 open and closed cycles at -5 degrees Celsius. The Model 3, under similar reported conditions, reaches approximately 170 cycles before performance degrades. That gap is not a minor improvement, it is a fundamental redesign. I want you to pause on that number. 170 cycles versus 980. If you live in Minnesota and open your car door twice a day from October through March, that is roughly 360 cold weather cycles in a single year. Under reported Model 3 performance, your handle is already degraded before spring arrives. Under the reported Model 2 design, you are still well within range after nearly 3 full winters. That kind of engineering never shows up in a comparison review, but it shows up very clearly on your repair bill. Tesla is also reported to have reduced the number of moving parts inside the door handle mechanism from 9 components down to 5. Fewer moving parts means fewer friction points, fewer potential failure locations, and lower replacement cost when service is eventually needed. And here's the calculation that actually matters. If a door handle failure on a modern vehicle with embedded electronics costs anywhere from $400 to over $800 to repair properly at a dealership, and that failure happens twice in a 10-year ownership window, you have just spent $1,600 on a piece of hardware most people never even think about at purchase. Now let us talk about the mirrors, because most drivers do not realize how much those 2 side mirrors are quietly costing them every year. The Model 2 reportedly increases surface area from 35 to 39 square inches, which expands the driver's field of vision and reduces the blind spot angle to an estimated below 1.9 degrees. At highway speeds, detecting a vehicle in your blind spot 0.3 seconds earlier is the difference between a smooth lane change and an emergency swerve. That is not a comfort feature. That is an accident prevention feature. And preventing one collision, even a minor parking lot scrape, saves you between $800 and $4,000 depending on the damage. But there's also an energy efficiency angle most people overlook. At highway speeds above 60 miles per hour, aerodynamic drag accounts for more than 60% of total resistance. The Aeroflow wheel covers extend this further, improving overall efficiency by an estimated 5.4% and adding roughly 22 to 25 kilometers per charge cycle. Over 5 years of ownership, those small gains stack into a real number on your electricity bill. This is the engineering philosophy that separates a machine designed to look good in a showroom from a machine designed to cost less to own after the cameras stop rolling. Small savings stacked systematically compound into financial protection. That's what the Model 2 is reportedly built around. And that brings us to the chapter most YouTube channels skip entirely because it requires you to think about what you are not buying and why that protects you.
The philosophy of enough. Why not chasing the newest technology protects you. Here is a sentence that goes against everything the technology industry wants you to believe. The most expensive car to own is often not the cheapest car to buy. It is the car that forces you to upgrade, update, or replace major components just to keep it functional a few years after purchase. Tesla reportedly made a very specific decision with the Model 2 that most people criticize without understanding. They did not build it around their newest and most powerful chip. The AI-5 processor, Tesla's next-generation autonomous driving computer, is reported to enter pilot production in 2026 with limited output and is not expected to reach large-scale production until 2027. New generation chips in their first 2 years of production typically carry a 20 to 30% price premium over established hardware. They also carry higher defect rates and less predictable repair costs, simply because the supply chain has not yet matured. Now, I know some of you are going to push back on this in the comments, and I want you to. The argument goes, if Tesla is using older hardware, the Model 2 will be obsolete faster. You are buying yesterday's technology at today's price. That is a fair challenge. Here is the counterpoint. A chip that has already operated across millions of vehicles has had its failure modes identified and corrected. The repair infrastructure exists. Parts are in stock. The early adopter premium has already been paid by someone else. For a person who needs a vehicle to work reliably for the next 10 years on a predictable budget, that is not a limitation. That is a feature. The question is not whether you want the newest chip. The question is whether you can afford the uncertainty that comes with it. Tesla reportedly chose to base the Model 2 on their current proven hardware platform, the same foundation already deployed across millions of vehicles worldwide. That decision delivers 3 concrete benefits. Stable component pricing because parts are no longer at an early adopter premium. Higher real-world reliability because failure modes have already been identified and corrected at scale. And lower repair cost because shared hardware across multiple models keeps parts in stock and labor time short. The central computing system, the FSD computer and its associated hardware, represents one of the most expensive repair categories in modern electric vehicles. U.S. repair data from 2023 to 2024 estimates full system replacement at approximately $2,000 to $4,000, not including labor or diagnostic time. Tesla's current onboard computers are reported to maintain approximately 30 to 40% processing headroom above real software requirements. Headroom that exists to absorb software updates over years without forcing a hardware replacement. A battery management system that cannot handle updated software protocols can reduce battery lifespan by tens of %, which translates directly into range loss, reduced resale value, and replacement cost measured in thousands of dollars. The Model 2 is not built for the person who wants the newest thing. It is built for the person who needs the thing to work correctly 5 years from now without an unexpected bill that disrupts their retirement budget. And that brings us to one final category of hidden costs, the ones Tesla is reportedly engineering out before you ever sign a purchase agreement. According to automotive warranty data, camera and sensor-related failures account for roughly 15 to 20% of all issues that directly affect driver assistance systems.
For a vehicle like the Model 2 that relies heavily on cameras as its primary sensing system, a dirty or malfunctioning camera is not just an inconvenience, it's a safety gap. Tesla is reported to be addressing this with a self-cleaning rear camera system, which reduces the driver's dependence on remembering to clean the lens after rain, mud, or snow. The camera-based mirror replacement also deserves a clear-eyed financial assessment. According to U.S. insurance data, replacing a modern powered side mirror can cost between $800 and over $1,500 after a minor impact, not because the technology is complex, but because the motor assembly, the heating element, the turn signal integration, and the body panel paint matching all stack into that bill very quickly. Replacing that mechanical system with a fixed camera reduces moving part count, eliminates several failure modes, and decreases the complexity that translates into labor hours during service. Every one of these decisions points in the same direction: fewer things to remember, fewer things to break, fewer things to explain to a service advisor while you wait in a lobby for a bill you did not plan for.
Fewer things to break. Fewer bills you didn't plan for. Fewer mornings starting with a phone call from a service advisor. That's the factory logic. That's the material logic. That's the "how is this price even possible?" answer. But now I want to shift gears, because there's a layer underneath all of this that almost no automotive coverage ever gets to. It's not about what's cheaper to manufacture. It's about what was designed specifically around the body of a person who has been driving for 40 years. The back that gets stiff, the knees that have opinions, the fatigue that builds on a 4-hour highway run. 7 decisions, each one made for someone specific, and I think you'll recognize yourself in at least 3 of them. Before we go there, comment "factory" if something in the last section changed how you think about what you're actually paying for in a car. And comment "ready" if you're already thinking about this as your next vehicle. I want to know where you're at before we get to the most important part.
The philosophy shift nobody's talking about. For 20 years, Tesla built cars around one question: how fast can it go? 0 to 60 in 3 seconds, ludicrous mode, the longest range, the biggest screen. That's not what they're building now. According to multiple sources close to Tesla's engineering team, the Model 2 was designed around a completely different question: how long can a retired American keep this car without it costing them their peace of mind? That's a different car, built for different people. And if you're watching this channel, there's a good chance that second question matters a lot more to you than the first. Here's what that philosophical shift looks like when it hits the actual hardware, because this is where the money either stays in your pocket or slowly disappears. Decision 1. The wheel you almost never notice. Most people glance at a car's wheels and think about style. Tesla's engineers apparently looked at the front wheels of the Model 2 and thought about your monthly electricity bill. Leaked specs indicate the Model 2 front wheels are narrower than anything Tesla has built before at this size, likely running a 195 to 205 width compared to the 235 width you'd find on a Model 3. That's not an accident. That's not a cost cut. That's a deliberate engineering decision rooted in one principle: a narrower tire pushes through air and rolls across the road with significantly less resistance. Less rolling resistance means the battery doesn't have to work as hard to move the car at highway speed. Engineers estimate this design alone could contribute 3 to 5% improvement in overall efficiency. On a 250-mile range car, that's 8 to 12 extra miles per charge. Now you might be thinking, 8 miles? That doesn't sound like much. Think about it differently. That's 1 less charging stop per week for most drivers over 65. Over a year, that's 52 charging sessions you don't have to plan around, sit through, or worry about. Over 10 years of ownership, that's real time back in your life and real dollars saved on electricity. The wheel you barely noticed just changed how often you have to stop on the way to your daughter's house. Decision 2. Why the rear wheels are built to outlast you. If the front wheels are about efficiency, the rear wheels are about durability. And this is where it gets interesting for anyone who plans to own this car past year 7. Sources indicate the rear wheels on the Model 2 will run a larger diameter, likely 20 to 21 inches on the drive axle, paired with a relatively tall sidewall for the size. Here's what that means in real mechanical terms. A larger diameter wheel completes fewer full rotations per mile. Fewer rotations means less total mechanical stress on every bearing, every hub, every component that touches that wheel system over the life of the car. That is not a small thing. Suspension wear is one of the most common and expensive long-term repair categories on any vehicle. Struts, control arm bushings, wheel bearings, these are the parts that quietly degrade over years of driving and then hit you with $800 to $1,500 repair bills right when you thought the car was paid off and running clean. If Tesla's design holds, the rear axle geometry on the Model 2 could meaningfully reduce suspension component wear over a 100,000 to 150,000 mile ownership cycle. That's not a brochure claim. That's physics applied to your retirement budget. And here's a question worth sitting with. When was the last time a car manufacturer designed a vehicle assuming you'd still be driving it at 180,000 miles?
Decision 3. The one design choice that could save you from a terrible day in a parking lot. Picture this. You're at the Costco lot. You're backing out slowly, the sun's in your mirror, and the left front wheel catches the concrete curb hard. On a modern alloy wheel, the kind that's on almost every car sold in America today, that one moment can cost you $350 to $600 to replace a single wheel. On some EVs with low-profile performance tires, you're looking at $700 to $900. Leaked photos and supply chain data suggest Tesla is equipping the Model 2 front wheels with steel construction, not the polished alloy that makes cars look expensive in showroom lighting. Steel wheels are heavier, yes. They're also dramatically cheaper to produce, dramatically more resistant to curb damage, and when they do get damaged, dramatically cheaper to fix. We're talking $85 to $140 for a replacement steel wheel versus $400 to $900 for an alloy equivalent. Over 10 years of real-world driving, grocery runs, doctor appointments, the inevitable parking lot that was a little tighter than it looked, that difference adds up. But more importantly, it removes a specific kind of financial surprise that nobody on a fixed income should have to absorb. Tesla didn't make this choice because they ran out of money. They made it because someone in that engineering room understood that retirement means you've already dealt with enough surprises.
Decision 4. What your back noticed before your brain did. This one is personal for a lot of people watching this channel, and I want to spend a moment on it. If you've ever climbed out of a low, sporty car and felt it in your lower back for the next 2 hours, you already understand what suspension tuning means in your body. You don't need an engineering degree. You felt it. The Model 2's tire spec shows a notably taller sidewall ratio than most modern EVs in its class. We're looking at a 55 to 60 series sidewall compared to the 35 to 40 series low-profile setups that define most current electric vehicles. That taller column of rubber acts as a natural shock absorber between the road surface and the chassis. Independent ride testing data on prototype platforms using this sidewall configuration shows a 15 to 22% reduction in cabin vibration at typical highway speeds compared to current low-profile EV setups. On a bad road, and there are a lot of bad roads in this country, the difference is not subtle. For someone dealing with arthritis in the spine, recovering from a hip replacement, or simply 68 years old with decades of miles on your body, that 15% difference isn't a statistic. It's whether or not you arrive at your destination feeling like yourself. This design decision costs Tesla almost nothing extra. It's a choice, and it says something about who they designed this car for.
Decision 5. The stability equation that keeps you out of trouble at 70 miles per hour. Here's something that doesn't get discussed enough in EV coverage: weight distribution and what it does to a tired driver on a 4-hour highway run. The Model 2's structural battery pack is mounted low and centrally in the floor, a configuration that pushes the center of gravity down below the seat level. This isn't new for Tesla, but the Model 2's smaller, lighter form factor concentrates this effect more than any vehicle they've built before. What does a low center of gravity actually feel like in practice? The car responds to steering input precisely and predictably, without feeling nervous or darty. You don't spend subtle energy constantly micro-correcting. You don't feel the car wanting to lean hard into corners. It tracks straight on the freeway the way a good road feels, effortless. For a 67-year-old driving from San Diego to Phoenix to see the grandkids, that difference in physical fatigue over 4 hours is real. Driving a car that fights you, even subtly, costs you energy you don't see leaving. Driving a car that's settled and stable gives it back. Engineers who've driven pre-production configurations describe the highway composure as closer to a full-size sedan than a compact car, which is exactly what you want when you're hours into a trip and the sun is starting to go down. And staying alert on that kind of drive isn't just a comfort question, it's a safety question that matters more each year.
Decision 6. The part that breaks the repair cycle forever. This is the one that matters most for long-term ownership economics, and it's the one most people underestimate because the numbers seem too simple to be real. A conventional gasoline engine has somewhere between 2,000 and 3,000 individual moving parts: pistons, crankshafts, camshafts, valves, timing belts, water pumps, oil pumps, injectors. Each one is a scheduled maintenance item or a potential failure point. Each one generates revenue for someone every time it needs attention. The Model 2's electric drivetrain, based on Tesla's next-generation single-motor rear-wheel drive architecture, has approximately 17 moving parts in the powertrain itself. That's not a rounding error. That's a fundamental structural difference in how likely this car is to develop a mechanical problem after year 5. Industry data from existing Tesla vehicles shows that owners spend an average of $370 per year on maintenance, compared to $1,200 to $1,400 per year for a comparable gasoline sedan. Over 10 years, that gap is between $8,000 and $10,000 in your pocket, not a mechanic's. But there's a layer underneath the numbers worth understanding. It's not just what you save, it's what you avoid. You avoid the Tuesday morning phone call that starts with, "Well, we got it on the lift and it turns out your transmission." You avoid the decision of whether to put another $2,400 into a car that might need another $2,400 6 months from now. You avoid the slow, grinding uncertainty that follows an aging car like a shadow. That peace of mind has a dollar value. It's harder to put in a spreadsheet, but it's real.
Decision 7. The hidden warranty that nobody puts on a window sticker. The final design decision isn't a single component, it's a philosophy embedded in every piece of the Model 2 structure, and it has to do with how long Tesla is engineering this car to last before it needs significant intervention. Tesla's structural battery pack, the same fundamental design carrying over to the Model 2, serves a dual purpose. It's the energy storage system and the structural floor of the vehicle simultaneously. This means the battery casing itself is load-bearing, made from aerospace-grade aluminum alloy, sealed against moisture intrusion to a level far beyond standard automotive practice. Current LFP chemistry batteries being targeted for the Model 2 are rated for 3,000 to 4,000 full charge cycles before meaningful capacity degradation. If you charge once per day, which most retirees driving under 50 miles daily would not need to do, that's over 8 years before you'd notice any range reduction. If you charge every 2 to 3 days, which is far more realistic for typical retirement driving patterns, you could be looking at 20-plus years of battery life. Tesla's expected to back the Model 2 battery and drivetrain with an 8-year, 150,000-mile warranty, but the engineering intent appears to reach well beyond that window. What this means in plain terms, if you buy this car at 67, there is a reasonable engineering case that you will never need to buy another car, not because you gave up on quality, because the car was built to outlast the need to replace it. That's the quiet revolution here, not the price, not the range, not the technology headlines. The real story is that someone in Tesla's engineering department sat down and designed a car around the idea that a retired American should be able to buy one vehicle, drive it with confidence, and never face the anxiety of doing this again.
Who this car is and isn't for. We're going to be honest here, because that's what this channel exists to do. If you're driving under 12,000 miles a year, doctor appointments, grocery runs, visiting family, the occasional longer road trip, and you intend to keep the next vehicle you buy for at least 7 to 10 years, the engineering philosophy behind Model 2 lines up almost perfectly with your actual life. If you can charge at home, even from a standard 120-volt outlet overnight, the economics work without needing to plan around public charging stations. You wake up every morning to a full car. That's a different relationship with transportation than you've ever had before. If you value predictability over performance, if you'd rather have a car that costs you $370 a year to maintain than one that does 0 to 60 in 4 seconds, this car appears to have been built with your priorities in mind. But there are people who should wait, and saying so clearly is part of the job. If you regularly drive 200-plus miles in a single day, the Model 2's expected range may create real inconvenience, not just abstract concern. If you live in a northern climate and park outdoors in winter, LFP battery chemistry loses 25 to 35% efficiency in extreme cold, which changes the practical range significantly. If you trade cars every 3 years because you enjoy having the latest model, this is a long-term ownership vehicle, not a cycling vehicle, and the economics don't work the same way. The honest answer is that this car is not for everyone, but for a specific kind of buyer, it may be the most rational vehicle purchase available in the next decade.
This hour was never about a car. It was about a decision. The Model 2 has not been officially announced. The price has not been confirmed. The specs are from leaked sources. Some will prove accurate, some will not. But the engineering philosophy behind them, building a car that costs less to own over 15 years instead of looking impressive on a test drive, that lines up with something real. What the car in your driveway right now will cost you over the next decade if nothing changes. Before you close this tab, one comment. Comment "last car" if you genuinely believe this could be the last vehicle you ever need to buy. Comment "not yet" if something is still holding you back. One sentence telling me what it is. Those comments become the next video. Comment "waiting" if the situation fits. Home charging, under 12,000 miles, long-term ownership, but you need confirmed specs before you move. This channel doesn't sell cars. It doesn't have affiliate deals. It sits here with you before the decision, not after. Hit subscribe. The next video goes deeper. The Pi phone, the insurance question, the cold weather reality nobody puts in a brochure. Subscribe, drop your comment, and I'll see you in the next one. Drive safe. Don't let anyone pressure you into a decision you're not ready for.